Hey, what's up, guys? This is Chung here again. So this time, number 1942, the number of the smallest unoccupied chair. Uh, so we have n friends, right, from 0 to n minus 1, and we have an infinite number of chairs in the party that are numbered from 0 to infinity. So when a friend arrives at the party, they sit on an occupied chair with the smallest number. Obviously, this chair, we don't need an infinite number of chairs. We need at most n chairs, right? Because n chairs will be enough for n friends. I don't know. I don't know why they highlight this infinite. Okay, so for example, if chairs 0, 1, 5 are occupied, when the friend comes, they will sit on chair number 2, right? And when the friend leaves the party, so their chair becomes unoccupied at the moment they leave. And if another friend arrives at the same time, they can sit on the same chair, right? And then given like a 2D integer, right, where the times have arrival and leaving, right, indicating the arrival and leaving time of the i's friend respectively, and an integer target friend. Okay, so return the chair number that the target friend will sit on. Right, so that's the description. Right, so for example, we have 3 persons, right, who will be arriving at different time. So the first person will arrive at time 1, right? The second person will arrive at time 2, and third person will arrive at time 4. And so the target friend is that we want to check which chair the friend index number 1 will be sitting on, right? So obviously, so for this one, the answer is 1, because friend 0 will come first, right? And then he will sit on the index 0, right? And then when the index 1 friend comes, and he can only sit on the chair index 1, because the index 0 has already been occupied by the first person, right? Which has not left yet, right? And then here is another one, right? Basically this one, so the target friend, now we're trying to look for friend 0, but obviously this one, the friend 0 will come to the end, will come the last, because friend 1 will come first, and then the friend 2, and then the last one is this one. So obviously, okay, so we have this kind of standard constraints. So obviously the first thing we need to do is that we have to sort, right? So we have to sort all the times by the arrival time, because that's the only way we can make sure, right, the each person can sit correctly. Okay. Right, and then the second one is like what? The second one is the so when the first person, when each of the person comes, right, we have to know, right, which chair can it sit on, right? I mean, the brute force way is that we simply just scan all the chairs from the smallest to the biggest, right? And then we check if this chair has been already is occupied or available, right? If then we just return the first one, right, which is available, right? And meanwhile, we also need to try to release, right, the each chair, right, by the current arrival time. But that will obviously it will TLE, right, because that will be an n squared time complexity, right? So a simple fix is that we can use priority queue, right? Because priority queue is a convenient like data structure that can convert the O of n time complexity into O of log n time complexity if what we need is the smallest value or the biggest value, right? In this one, is exactly what we need, right? We want to find the smallest number, which is a perfect candidate of using the priority queue. Okay, so what So what we need is actually we need two priority queue, right? So the first one is for what? The first one is for the available chairs, right? So for the available chairs, and the second one is a used chair, okay. Available chair, this one is pretty straightforward because we need to use this available chair to give us all of one, to help us find the first available one, right? But for the used chair, the reason we use a priority queue is that, given like arrival time, right? Arrival time here, we can simply use this arrival time to pop all the chairs that have already been freed up until this arrival time by using this priority queue, right? We simply just pop the chairs out of the priority queue until the first one is greater than this arrival time, right? So I think that's it, right? So it's just two priority queue implementation. Yeah, so let's do it. Since we need to store the times first, but we still want to obtain the original index. The reason being is that because we need this targeted friend, right, to use this times index, right? After sorting, the original index is gone, but we still need to find which person is for this target friend, right? That's why I'm going to create a expansion, right, of the current time, which is arrival and leaving, and then the index, right, for I dot arrival leaving in enumerate, right, times, and then we have times dot sort. Okay, we sort, right? Now we need two priority queue, right? So the first one is available chairs, right? It's gonna be at the beginning everything is available, right? That's why we have of n, but we have to heapify it, right? Okay, we need to heapify this entire list, and then we have use chair. Okay, it's gonna be another priority queue, right? So we simply just loop through the times from the earliest to the last, arrival, leaving, and I in times, right? So first, free all chairs, all used chairs whose arrival time, leaving time, right, is either equal or smaller than this A, right? That's what we need to do first, because the moment the chair gets freed, this person can sit on it. Okay, it's gonna be we don't need the leaving anymore. All we need the index. The index will be the heap pop of the used chair, right? So here we stored two things, right? It's gonna be the leaving and then the index, right? And where this one is obvious, this one is simply just the index, right? Chair index. That's why we have this one, and then after this one we're gonna add it back to the available chairs, right? It's gonna be heap push of available chairs and then the index, right? So for the available chairs we don't need the any time. All we need is the index itself. Okay. Oh, so what am I doing? We haven't even write the while loop here. So while the used chairs are not empty and these used chairs, first one and the first one, right, is either smaller or equal than this arrival time, then we do this, right? Now for the current index, right? So we have current one, which is going to be the pop of available chairs, right? So this is the index the current person will sit, okay? And then if the I is equal, then equal to target friend, right? We simply return the current, right? And then in the end, don't forget to push the current person's chair to the used chair, which is going to be the leaving and then the current, right? So that's it. Run it. Range. Oh, sorry, I forgot to do this. Length of times. Okay. Yeah, I think that's it, right? Yeah, I don't know. I think that's it. It's pretty standard uh, priority queue problem. I would say that. Maybe there are other like solutions, but to me, the priority queue is the most straightforward one because, like I said, it helps us to get the smallest value in login time, right? Which is exactly what we need for this problem. And yeah, we just keep maintaining two priority queue. Yeah, I think that's it for this one. And thank you for watching this video, guys. Stay tuned. See you guys soon. Bye bye.